Hey guys, welcome back to my channel. Today we'll be discussing a little more about operating systems. So firstly, as we've discussed in our previous video, we know what a kernel is. Now where does the kernel reside? The kernel is actually present in a protected space in the memory. It has full access to the hardware resources as we've discussed in the previous video. And the system state and the memory space that are used by the kernel are collectively known as the kernel space. Okay, and the user space is called basically all the applications run in the user space. We've discussed how they access the hardware resources. They have to go through the kernel space. We've discussed this diagram before, so yeah, that's how it is. The applications run in the user space. Any instruction they need to execute or anything that they need to do should go through the kernel space if they want to access the hardware. So we've seen this before. Now moving on, what are system calls? What is a system call? A system call is basically a programmatic way in which the application or a computer program requests the kernel to perform some action, okay, on the hardware or whatever. System calls, what do system calls do? They enable abstraction because the user does not know what actually is happening. Protection, it helps us understand, and it protects the because if you give user direct access to the hardware, anything can happen. So instead it goes through the kernel, so it provides protection and fault isolation. We can understand where the mistakes are happening. Now, system calls, like only those have the access to the system call open. While some libraries share many-to-one relation, like printf can be used by anybody, right? So that is how some libraries have many-to-one relation with system calls. Now, like I always do, I'm going to ask you a few questions. You can answer in the comment section below and I will give you the answers a few days later. So firstly, identify what happens when the user C program calls printf. Like for example, user C program is basically an application level program, right? As we have discussed. So what happens when the user program calls printf? Show me the steps, okay? The next question is, how many other calls make it to eventually access the display? That is the screen. Like when you call printf, how many other calls have to be made to access the screen? That is to actually print on the display on the screen. Okay. Now another one is so you can explore many different C library function calls. Check out what other function calls are there in the C language. Okay. Moving on, can any application execute a system call? How is protection ensured if applications can execute system calls? Applications request to execute system calls to the kernel space. Basically, they request the kernel space to execute a system call. The kernels actually execute the system calls on behalf of the applications. So, to answer our first question, the application cannot execute a system call. It can only request the kernel to execute for a system call, and the kernel actually executes the system call. So therefore it's protected. If the kernel finds something suspicious, it will not execute the system call that is requested by the application. Now moving on, do you know what interrupts are? Interrupts are a way in which the device can talk to the processor. So for example, when your program is running, if it's taking too long, or if you feel that there's something wrong with your program, you click Control C, right, to stop the execution. So that is one example of a keyboard interrupt. So you're interrupting with your key, that is with your hardware, interrupting the execution on the processor. So that is one example of an interrupt. So interrupt is a way in which the device talks to the processor. Okay. Now how does the operating system handle such interrupts? So when a hardware interrupt occurs, will the OS create a separate process? No, it does not. it runs in a special context called interrupt context. So basically in an operating system we have two contexts, process context and interrupt context. So the process context is the place where the processes run or execute, and the interrupt context is where we get the interrupts and action on them will be taken. Okay, so this is what happens when the operating system gets an interrupt. Now the state of the processor has three states with respect to the operating system. It is either executing the user code in the user space, or it is having the system calls that are executing in the kernel space, or it is executing in the process context, or it is executing a system call in the kernel space in the interrupt context. Okay, so the user code, as we've said, that is the application runs in the user space. So in the user space, the user space code runs in the process context. Also, the system calls in the kernel space, some of them run in the process context. That is, if it's a process, they run in the process context. And system calls also run in the interrupt context. That is, if we have a hardware interrupt, like a keyboard interrupt. Okay, so these run in the kernel space. So these are the three states of the processor with respect to the operating system. These are the three tasks that the processor performs with respect to the operating system. Okay, now moving on, what is a process? A process, as we've discussed earlier, is a program in execution. Okay, so a process is an entity. It is something with distinct and independent existence. Okay, as we've discussed earlier, each process has three sections. Text section consists of the code the processor executes. Data consists of the stored variables and dynamically allocated memory that the process uses during execution, and the stack section that is used for function calls. Okay, now we've discussed this also yesterday in the previous video. What is a program? What is a process? Program is an inanimate entity that is present in the hard disk, while a process is a program that is in execution in the main memory. Now, why is a process's address space divided into multiple regions? Please do answer in the comment section below. Now, what is the life cycle of a process? This is something that is very interesting. A process can have many different states. What is the life cycle of a process? So during the lifetime of a process, it moves through different discrete process states. Okay, so various events can cause a process to change its state. Let's look at them in detail. Firstly, the first state is running, as we already know. That is, the process is being executed in the processor. That is one state. Another state is that a process is ready to get executed. That is, if a processor is available, it can get executed easily. Blocked, if it is waiting for some event to happen before it can proceed. Like for example, it is waiting for input. Like in C programming or in any programming language, we take input of the data, right? So it is waiting for the input, for the user to give the input. Then that is called the blocked state. Then moving on. So basically these are the different states that we have, and here we have a process life cycle diagram. So the process is first created, it is then admitted, and it is ready to be executed. Once the processor is available, it gets into the running state. Then it comes into the blocked or the waiting state. That is, it is waiting for input, output, or whatever. Sometimes when the process is running itself, it doesn't need any input and it's completed, then we terminate it. So the process has the created state, the ready state, the running state, the waiting state, and the terminated state. Okay, so for example, if somebody causes an interrupt, it goes into the ready state. If it is waiting, in the running state it needs an input or output, it goes into the blocked state, and once the input or output is given, it moves into the ready state. So this is how a process has different states in its life cycle. So if we take a general common process which has an input and output, first it's created, then it's moved into the ready state. Once the processor is available, it gets into the running state. If it needs an input or output, it moves into the waiting state. Once the input or output is given, it goes to the ready state, then it's again running, and then if the process is completed, it moves to the terminated state, which is the process is complete. Okay. Our next topic is process control blocks. The operating system performs several operations when a process is created. Each process has a unique process ID. Okay. The OS also creates a PCB called process descriptor, basically also called process descriptor, which maintains information about the process that the operating system needs to manage it. So the information in the PCB are as follows. It has the process ID, the unique process ID, the state of the process, in the state of that particular process, the program counter, the priority of that process, the credentials of the data that the process requires to run, a pointer to the parent process, that is the process that created this particular process, the pointers to the child processes, that is the processes that are created by this particular process that we have, and the pointers to the resources that are allocated, like the path to the files or whatever other resources that the process requires. Okay. The PCB also contains the register contents that are basically the currently used variables or the data. The process table, it has a pointer to per user process table, which has access to the PCB, which helps us access the PCB. Now, this is the process table. Each process has a separate process control block, and the address to that process control block is available in the process table. Okay. So, with the process with the PID 1 has, for example, the address 123. Its PCB is located in the address 123, and this is the address 123, and this 123 is stored in the process table. So if the operating system wants to manage the process, or if it wants to take some action on the process with process ID 1, it checks for the PCB of the process ID 1 in the process table, that is 123, and it goes to the address 123 and it finds the process control block of the process ID 1, and it takes the required actions that it wanted to take based on the data present in the process control block. Now, moving on, I have another few questions. At any given time, only one process can be executing instructions on a computer. This is your first question. Name some events that might cause the process to enter the blocked state. I've already given you one example, input or output. Try thinking about some more events that can cause a process to get into the blocked state. Okay. Now, moving on. Now the next topic that we have is process management. That is, what are the actions that can take place on a process. We'll discuss this in the next video. Stay tuned, and please do like, share and subscribe if you like my videos.